Here's just a quick little theory that I have, just a little brain dropping in regards to movies that incorporate time travel in them. Now, I know that's not exactly one of the biggest problems facing this country right now, but nonetheless, it's an idea that I had, and I figured I'd get it out while it's fresh on my mind. Now, there is a problem with the way Hollywood makes time travel movies. And it's not just Hollywood either. It's anytime an author writes a book on the subject, there's a serious flaw that they're all overlooking. And old Jonesy here figured it out. All right. Now, I was just watching Back to the Future not too long ago, and now the style of time travel that they incorporate in that movie is the same kind of time machine that H.G. Wells had, which is the kind of time machine that only moves through time and not through space, as opposed to the Bill and Ted's route, where they have a time machine that moves through both time and space. But I've seen interviews before with physicists like Michio Kaku, where he explained that if there ever was a time machine to be built, it would be the H.G. Wells route. It would only go through time and not at all through space. So let's go with the physicists for a minute. They know what they're talking about. Let's say I want to go back in time 3 hours ago, right? Let's say, for argument's sake, I got a workable time machine right here. Let's say this chair is a time machine. Now, we want to go back in time 3 hours ago. I missed my favorite TV show, America's Biggest Piece of Crap, or Wiping Your Ass with the Stars, or whatever the hell they got on TV nowadays. I don't even know anymore. But, yeah, I missed my favorite TV show, and I want to, I missed the season finale. I want to make sure I catch it, right? So, according to theory, we should be able to go back in time 3 hours ago, and I should be in the same space right here. We don't move through space at all, only through time. I should be right here in my bedroom just 3 hours ago. Now here's the problem with that. All right. Now planet Earth, as we all know, travels. It rotates on its axis once every 24 hours. It actually moves at the speed of about 1,000 miles an hour over at its equator. A little bit slower the further away from the equator you get. And if you get on the North Pole, you're really not moving at all. Actually, you're just doing a little ballerina kind of a thing like that, right? But yeah, it moves in the eastward motion. Basically, if you look at it from the North Pole on, it goes in a counterclockwise kind of a motion. Now here's where the problem lies. You go back in time 3 hours ago, keeping in mind that the Earth is rotating on its axis. If you go back in time 3 hours ago, now I'm over here on the East Coast, 3 hours ago, this isn't where the planet was 3 hours ago. No. Let me move this thing over a little bit. 3 hours ago, the Earth was over here. Got to go over 3 time zones. That would actually bring us where? Somewhere in like the mid-Atlantic, probably, right? Probably somewhere over by where the Titanic is sunk. I don't want to go there. So there's going to have to be some adjustments. Some adjustments are going to have to be made. Maybe we might actually have to go the Bill and Ted route. Come to think of it, you're going to have to go and make it travel through space as well as time. Not through space in the aspect where you want to go to a different area, but you're going to have to travel through space in order to overcompensate so that you can be in this space, if that makes any sense. So if you want to go back in time 3 hours, you're going to have to overcompensate and figure out a way to go 3 hours westward. I mean, you got to be like exactly on the money too. You got to be like, the mathematics would have to be absolutely perfect. You got to be dead on by the nanosecond, by the nanometer. If you're off at all, that'll completely throw everything off. But you'd have to make a machine that travels through space and time in order for it to work. That's just the only way. Now let's just say in theory that we can get a machine to go through both time and space in the manner in which I want it to. In order for it to work, Yeah, you'd have to overcompensate and go 3 time zones over in order for it to magically be over here on the East Coast by the time you get there. It's probably a better way of explaining that, but beats the hell out of me if I could find it at this point in time anyway. It's like, but yeah, that pretty much sums that problem up, right? If Hollywood or the authors, screenplay writers solve that little dilemma, then we could start making some time travel movies that make a little bit more sense, right? Wrong. Because that now opens up to a whole new plethora of problems. Not only does the Earth rotate on its axis, but it also revolves around the sun once every 365 days. It actually moves at a speed of about 66,000 miles an hour. Yeah, Earth's orbit's pretty big. So if it moves 66,000 miles an hour, that means you're going to also have to factor in with, let's say we go back in time 3 hours. 66 times 3, 132, 198. So it'd be 198,000 miles back that away. And it can't be just a straight line either. It would have to be like, you have to factor in the curvature of the orbit. So you have to be pretty exact with these mathematics. It's just getting crazier and crazier. But yeah, like I said, you got to be dead on with these mathematics. Boy, I mean, if you're off by just a little bit, even just the littlest bit, that could mean that that could mean the difference between you getting stuck inside of the wall, or if I'm just 6 feet over that way, that would bring me outside of the house. This house is up about 4 feet. It would be like one of those scenes from a Looney Tunes cartoon where you look down and you realize you're up in the air, then you plop down and fall on your ass. Anyway, once you factor all that in, then we could start talking about having a movie or a book that does it the right way, right? Wrong. Because unfortunately it doesn't end there either. Nope, not only does the Earth rotate on its axis, not only does it revolve around the sun once every 365 days, but the solar system itself is actually moving throughout the galaxy. It's actually moving at about, 43,000 miles an hour in the direction of the bright star Vega. Yeah, that really complicates things. It's not even worth building a time machine at this point, is it? It's like a real lot of work. But if you did want to, that would be the way that you would have to do it, right? Wrong. Because it gets, the rabbit hole gets even deeper yet. Not only does the Earth rotate on its axis, not only does it revolve around the sun every 365 days, not only is the solar system moving around throughout the galaxy, but the galaxy itself is spinning around. It's like a big pinwheel. And our solar system is actually on one of the galactical arms of the Milky Way galaxy. And that's moving at about, let's see, I got this written down actually. That's actually moving at, what do we got here? 483,000 miles an hour. That's right, we're moving at 483,000 miles an hour on our galactical arm. It actually takes 225 million years for the galaxy to do a full rotation. So you got to factor all that shit in. But, well, that's the price for traveling back in time, right? Wrong, because there's still one more thing that you got to factor in. The entire galaxy, the galaxy itself is actually moving. It's actually moving, it's moving real fast. Real fast. Check this out. It's moving 1.3 million miles an hour. It's moving in the direction of the constellations Leo and Virgo. That's the direction that the galaxy is moving in at 1.3 million miles an hour. Uh, it's pretty hard for. I mean, I give the scientists credit for figuring that shit out. They figured out a while ago that there's this shit called cosmic background radiation, where they figured out, it's actually microwaves left over from the Big Bang, and that gives us a bit of a reference point as to where in absolute space we are. And if you travel back in time, you're gonna have to. You would go back in time in relation to absolute space, not Earth space. So, absolutely, all of those would have to get factored in order for it to work. Uh, that should about do it, right? No, that's right. I think.